Question 3, A, given the function f of x is equal to the modulus of 3x plus 1 plus the modulus of x minus 2. Part 1, we define f of x by removing the modulus. 2, sketch the graph of f of x. 3, find the values of x for which f of x is greater or equal to 6. So how do you do that? Say, okay. So this is question 3A to exam 1. Question 3A, the function f of x is given as 3x plus 1 plus x minus 2. This is a sum, the modulus function, the modulus functions. So you first pick the individual modular and redefine. So this is going to be the same as 3x plus 1 when 3x plus 1 is greater or equal to 0. This is going to be negative 3x plus 1 when 3x plus 1 is less than 0. Now, this is the same as saying 3x plus 1 is equal to 3x plus 1 when x is greater or equal to negative 1 over 3. Because we know how to solve this, and see when we solve that one, we'll get this inequality there. And then you expand negative 3x minus 1 when this is less than 0. When this is less than 0. So when you solve 3x plus 1 less than 0, you get 3x is less than negative 1. Divide by 3, divide by 3. So x is less than negative 1 over 3. So when x is less than negative 1 over 3. Like that. The paper in the group. I can't see it. Oh, okay. Look, I've sent. So we are done for the modulus of 3x plus 1. Then we get the modulus. We get the modulus of x. We get the modulus of x minus 2. This is defined as x minus 2 when x minus 2 is greater or equal to 0, negative x minus 2 when x minus 2 is less than 0. But this is the same as having x minus 2 when x is greater or equal to 2, or negative x plus 2 when x is less than 2. This is the modulus of x minus 2. Then now, you form a table using these two numbers, 2 and negative 1 over 3. So you have negative 1 over 3 and you have positive 2. There is this interval here where x is, where negative 1 over 3 is less than x, but x is less, of course here is less or equal to, and then x is less than 2. And in the other interval, we are saying x will be greater or equal to 2. In that interval there, all right. And then the other one, x is less than negative 1 over 3. So we have three intervals. 1, 2. So we have 1, 2, 3. Now I want to see what happens to the function in these intervals. Okay, so the pieces of the function that we have. The first piece that we have is the modulus of 3x plus 1. The second piece is the modulus of x minus 2. And then we'll have the whole f of x. So what is the modulus of 3x plus 1 when x is less than negative 1 over 3? What is this modulus when x is less than negative 1 over 3? It is...
Sir, may you please repeat on how you're grouping the intervals?
So we are picking the numbers negative 1 over 3 and 2. So I want to see what happens in between negative 1 over 3 and 2, what happens after 2, and what happens before negative 1 over 3. So we're saying in this interval here, x is less than negative 1 over 3. In the middle interval, negative 1 over 3 is less or equal to x, which is less than 2. And in the other interval, x is bigger or greater than 2, or equal to 2. So it's greater or equal to 2. That's how you break your intervals. Now, when x is less than negative 1 over 3, how have we defined the modulus of 3x plus 1? The modulus of 3x plus 1 is defined as negative 3x minus 1 when x is less than 1 over 3. So we have this defined as negative 3x minus 1. But when x is greater than negative 1 over 3, this very function is defined as 3x plus 1. 3x plus 1. Then for x minus 2, when x is greater than 2, this function is defined as x plus 2. As x minus 2. When x is greater or equal to 2. And anything less, the function is defined as negative x plus 2, negative x plus 2. Now for us to have f of x, we add, because we have a plus here. So we pick each piece and go to the plus. So add negative 3x plus negative x, we'll get negative 4x. Then negative 1 plus 2, we'll get plus 1. The second one, 3x plus negative x, we'll get 2x. Then 1 plus 2, we get 3. 3x plus x, we get 4x. 1 minus 2, we get minus 1. So we're saying f of x is actually defined as a piecewise function now without the modulus. It is negative 4x plus 1 when x is less than negative 1 over 3. It is 2x plus 3 when negative 1 over 3 is less or equal to x, which is less than 2. And it is 4x minus 1 when x is greater or equal to 2. We can now sketch this function. And the sketch is dependent on two numbers, negative 1 over 3 and positive 2. So when x is less than negative 1 over 3, we are doing the function on top. So if I substitute negative 1 over 3 in the function and get negative 4 by negative 1 over 3 plus 1, giving us 4 over 3 plus 1 over 1, which is 7 over 3. If you add as fractions, so we get 7 over 3. We have an open point here. And then pick any number that is less than negative 1 over 3 for you to see the direction. We can pick negative 2. You have f of negative 2 is equal to negative 4, negative 2 plus 1, which is 8 plus 1, which is 9. So we get 9, which is bigger than 7 over 3. So it means that even without indicating the 9 on the sketch, we know that our function is going to have this behavior on this side. So it has this structure. It's a straight line. Yes, that is drawn. That's curve. Okay. So this tool has no use now. It was just guiding us to know whether we should go up or down. So we're done with this function here. So we're done with the first piece. In the second piece, we get the same negative 1 over 3 and substitute it in f negative 1 over 3. But this time around, the f we're dealing with is this one here. So we have 2 by negative 1 over 3 plus 3. This is negative 2 over 3 plus 3 over 1, which is negative 2 plus that is 9 over 3, giving us 7 over 3. So go back now and close here, because this negative 1 over 3 we have used is included in this interval. So I have no option but to close what was open. And then in the interval negative 1 over 3 to 0, to 2, we are sure that 0 lies in this interval. So we can make use of 0, so it can tell us where the graph will touch the y-axis. So that will be 3. So we have 3. And then you substitute 2. What is f of 2? The boundary. You get 2 by 2 plus 3. That is 4 plus 3, which is 7. So we have
where is 3, sir? Above 7 over 3.
Where is 3? Oh, 3 is above 7 over 3. Okay. This is 7 over 3. And then 3 is here. Wonderful. And then when you place 2, we get 7. 7 is on top there. So and it will be open. So we can put up our sketch. Crosses here. Goes here. And then the last piece now, we have 4x minus 1. So you substitute 2 in here. You get 4 by 2 minus 1, which is 8 minus 1, which is 7. So we come and close here. And then pick a number bigger than 2. Say we pick 3. We'll have 4 by 3 minus 1, which is 12 minus 1, which is 11. So we get a number bigger than that in the sketch. Say 11 against 3. So it means that our sketch this side will have to go up. Which color now? Same color. This side the sketch is going a bit up. I can do this and move my point. That is 3,7 and 3,12. And now 3 can be removed. It has no use. We only want to indicate -1 over 3 and 2 as the x-axis. This is not drawing anything to scale. This is how the sketch will come out. So part A, we redefine the function, and this is the redefined form. 2, this is the sketch. 3, we want to solve f of x is greater or equal to 6, but f of x has been defined as.
Sorry, I've got a question on the previous page.
Yes.
On this part for when you're doing the modulus of 3x plus 1. I can continue.
Yes.
Yes, when you're doing the modulus of 3x plus 1, when you multiply the thing by -3, by -1, how come this side when you made x a subject of the formula, the sign of the equation didn't change?
This -1, this -1 is just for these two brackets here. It does not get extended to this one.
Yes, but then when you take this -1, the other side, it becomes +1. Then when you divide by -3 both sides, isn't the sign supposed to change?
You haven't gotten. You are talking about this one. But the definition,
Yes.
the definition is only having -3x plus 1, comma, when 3x plus 1 is less than 0. As far as the inequality is concerned, there's no negative. The negative is for the definition of the function. And not the inequality that we solve.
Okay.
I don't know if you get me.
Somehow.
Right. I didn't make on the somehow. On the other, how? When we define the function, in its redefinition, we have this. The inequality is not affected by the negative. The 3x plus 1 is greater or equal to 0. 3x plus 1 is less. The same 3x plus 1 that is greater or equal to 0 is the same 3x plus 1 that is less than 0 here. The issue of signs is here, this piece and this. The other one that will give us greater or equal to, the function will be positive. The one that will say less than 0, the function will have a negative. It is the function which will have a negative and not the inequality. So the inequality is not affected by the negative.
Oh, I mean, I don't understand in the parts of where you started drawing the table.
Okay. We have redefined this function in pieces. The piece 3x plus 1 in the modulus has been defined as 3x plus 1 only when x is greater or equal to negative 1 over 3. So on the table, negative 1 over 3 is here. Going this side, this function has been defined here as 3x plus 1. That's why we have 3x plus 1 here. As 3x plus 1, that's why we have 3x plus 1 here. Whenever x is greater or equal to negative 1 over 3. So going this side, x is bigger than negative 1 over 3. But when x is less than negative 1 over 3, this function here has been defined as negative 3x minus 1, which is what we have here. When we go to x minus 2 in the modulus, you will say this is equal to x minus 2 when x is greater or equal to 2. So when x is greater or equal to 2, in this box here, this function is x minus 2, according to this definition. But when x is less than 2, this modulus function is negative x plus 2. So it is negative x plus 2. It is negative x plus 2 whenever x is less than 2. Whenever x is less than 2. When x is less than negative 1 over 3, it's obvious it's less than 2. That's how the table comes about, and then you add on the last line.
So it's more like you're replacing x in the modulus. Yeah.
Come again.
To find the functions in the table, how do you find the functions in the table? For negative 1 over 3 and for 2.
You follow this inequality that you have here. Here you are saying the modulus function is equal to x minus 2 when x is greater or equal to 2. And the modulus function is equal to negative x plus 2 when x is less than 2. So when you find a table that has negative 1 over 3, that has 2, and it's saying this is the piece for x greater or equal to 2. And you're having this function. How do you define it? You define it as x minus 2 because x greater or equal to 2 in this interval. So you say it is x minus 2. When you find x is less than 2, you define it as negative x plus 2. When x is less than negative 1 over 3, no one should tell you that x is less than 2. For as long as it is negative, it will be less than 2. You can't come with x is equal to negative 5 and you are sure that it is less than negative 1 over 3. Then you get confused how it is less than 2. So it's an obvious case. For as long as it is less than negative 1 over 3, it will be less than 2. So in this case, you define it still as negative x plus 2. What you're defining in this way is the modulus function. Just as we have defined it in this says here. This is what you take on the table. So
And now what about the graph?
then the graph is just based on the concept of piecewise graphs. How do you sketch the graphs of piecewise functions?
There were a lot of x's. So I don't know what all of that was all about.
What do you mean there are a lot of f of x's?
Like at first you said when x is negative 1 over 3. Again, you said when x is 0, when x is 2. So a lot.
So in each x that we picked was falling in different intervals here. It's either it was in this interval, or the third interval. When we say x is 0, which interval do you find x is 0? When I say interval, I mean this is negative 1 over 3. This is 2. So when you say x is 0, you can't put 0 here. It's not bigger than 2. You can't put 0 here. It's not less than negative 1 over 3. You can only put 0 here. The same way, since f in this interval, it is negative 4x plus 1. F is negative 4x plus 1 here. And f is 2x plus 3 here. And f is 4x minus 1 here. So when you pick each x in any of these intervals, you substitute it in the function assigned for that interval. Okay, so we have very, very few minutes. We need to finish part 2. Part 3. The function is defined as negative 4x plus 1 when x is less than negative 1 over 3. And the function is defined as 2x plus 3 when negative 1 over 3 is less or equal to x, less than 2, and 4x minus 1 when x is greater or equal to 2. But we must solve for f of x is greater or equal to positive 6. So you pick each piece, say, okay, negative 4x plus 1 is greater or equal to 6, giving us negative 4x greater or equal to 5. And so x is less or equal to 5 over negative 4. You get 2x plus 3 greater or equal to 6. Take this other side. You have 2x greater or equal to 3. Divide by 2. Divide by 2. So x is greater or equal to 3 over 2. And then we have 4x minus 1 greater or equal to 6. And so 4x is greater or equal to 7. Divide by 4. Divide by 4. So x is greater or equal to 7 over 4. Meaning that we are picking each piece of f and taking it where it's f and say greater or equal to 6. Each piece of f greater or equal to 6. Each piece of f greater or equal to 6. Now here we have this one here. It is the same as saying negative infinite all the way up 5 over 4 negative. And this guy is included. Union. This piece here is saying that x is from 3 over 2 to infinity. Union. This piece here is saying x is from 7 over 4 to infinity. Now, which number is bigger than the other between 3 over 2 and 7 over 4? 7 over 4. 4 into 7 is 1, remainder 3. Point. 4 into 30 is 7, remainder 3. So I'm getting 7, 7, 7. Then 3 over 2 is 2 into 3 is 1 point, remainder 1. 2 into 10 is 5. So this guy is bigger than 3 over 2. So the solution is going to be negative infinity over negative 5 over 4 union 3 over 2 comma infinity. So you go to each piece of the function. Since each piece represents f, you pick each piece. The first piece, solve greater or equal to 6 is 1. The second piece, greater or equal to 6. The third piece, greater or equal to 6. And then get the union of those pieces. That becomes your function. And that becomes the solution set. We have 2 minutes for questions. When it cuts, we are not logging back. That will be the end of class.
Sir,
Yeah.
the previous page.
So you really don't have to miss class. If for any reason you manage to miss class, the videos will be uploaded. Please make sure that you watch so that in the next class, if there's any knowledge that you need from the previous class, you are able to connect. Because if you
So if the function there was a negative there, when finding the the function for the interval, you subtract.
Yes.
All right.
When finding f, we would have been subtracting the top piece minus second piece. Top piece minus second piece. Top piece minus second piece. So when you are saying top piece plus second piece, we are using the plus which is between the modules then.
Some I can't see the previous board.
And please, if you didn't write it,
No, back then.
Back.
Yes,
There's
the
no,
x-intercept, y-intercepts, it's not there.
it's not there, unfortunately. But it will be
All
posted,
right.
it will be posted on the video soon. So if you didn't write the exam, I demand an explanation. When I miss class, you follow me up.
So
As to why
with this one,
Sir,
hello.
Hello?
Yeah, with this, when finding the intervals as in the solution set, we don't follow that rule that we used to, like we get the positives, the negatives, if it's greater than, less than.
No, when it's union, that is not useful.
sir, but what was